In this video, we will discuss the definition and properties of normal curves. The graph of the camellia blossoms is highest with a diameter value of 15 centimeters, its center point, and rapidly and equally drops towards zero, but not reaching zero in both directions. A symmetric bell-shaped curve like this is called a normal curve. Any random variable whose graph has this characteristic shape is said to have a normal distribution. The area under the curve along a certain interval is equal to the probability that the random variables will have a value in that interval. Therefore, the area under the curve from one end to the other is 1. Normal curves are important in the study of statistics because many continuous random variables have normal distributions and many discrete variables are distributed approximately normally. Each point on the horizontal scale of a normal curve lies some number of standard deviations from the mean, positive to the right and negative to the left. This number is the standard score for that point and is the same as the z-score. By relabeling the horizontal axis with 0 as the mean and labeling the positions of standard deviations as 1, 2, -1, -2, and so on, we obtain the standard normal curve, which can be used to analyze any normal distribution. Every normal curve is defined by its mean and standard deviation. The standard normal distribution has a mean of 0 and standard deviation 1. Properties of normal curves. First, the graph is bell-shaped and symmetric around a vertical line through its center. The mean, median, and mode are equal and occur at the center of the distribution. The percentages of data values within given distances of the mean are approximately 68% within 1 standard deviation, 95% within 2 standard deviations, and 99.7% within 3 standard deviations. This last property is known as the empirical rule. For example, 300 pre-med students take a midterm exam and their scores can be treated as normal. Find the number of scores that are within 1 standard deviation of the mean. By the empirical rule, 60% of the scores, approximately, will fall within 1 standard deviation of the mean. 68% of 300 is 204 scores. Now we'll find the number of scores that are within 2 standard deviations of the mean. By the empirical rule again, about 95% of scores are within 2 standard deviations of the mean. 95 times 300 equals 285 scores.